Hello and welcome to Nature Connects, TNC in Massachusetts webinar series that connects you with scientists, experts, influencers, and our partners from New England and around the world. Thank you for joining us today. I'm your host, Tricia Daly, Offshore Wind Policy Manager for the Nature Conservancy. I coordinate TNC's offshore wind work to ensure that it can be used to meet our climate, conservation, and community goals. During today's webinar, we are going to be talking about whales. To most of us, these magnificent, intelligent, and seemingly gentle animals are symbols of a healthy and thriving ocean. We hop on boats to watch them. We adopt them to support research. We marvel at the way they communicate and are drawn to beautiful displays of their behavior captured by pictures and videos. This love of whales that we share means that we also worry about them. We are distressed when we hear about them becoming injured and heartbroken when they are killed. We want to understand why these injuries happen, and we want to make sure that humans aren't causing them harm. But many of the ways humans have long used the ocean, including for transportation, military activities, research, shipping of goods, tourism, energy exploration, and other resource harvesting, has often brought us in close proximity and conflict with whales. Ocean warming also is adding new stresses in this already stressed environment. Waters along the northwest Atlantic shelf, for example, have warmed more dramatically than any other waters in the world in recent decades. This means that finding ways to mitigate the risks and negative impacts on whales posed by all ocean activities, including from ocean warming, is critically important to their survival. We want to make sure that we understand what these activities, as well as any new pressures from offshore wind, may mean for these whale populations that are already at risk. Today, we're going to try to answer some of our top-of-mind questions about whales, like how whales use sound, what they can hear and what they can't, and why that matters. We will talk about what we know about recent whale deaths and how whales are being impacted by climate change and a variety of ocean activities. We will also talk about potential impacts from offshore wind activities specifically and how they are evaluated and mitigated. It is my pleasure now to introduce you to our guest speakers. Doug Nowacek is a professor at Duke University's Marine Laboratory. He has a PhD in oceanography and a bachelor's degree in zoology and animal biology. His work at the Marine Lab focuses on how marine mammals use sound in ecological processes. One of his specific areas of research is studying the effects of anthropogenic noise on marine mammals. And Jaclyn Daly is the Marine Mammal Protection Act offshore wind team lead with the National Oceanic and Atmospheric Administration's Office of Protected Resources. Today, we will use the acronym NOAA when we talk about this agency. NOAA's Office of Protected Resources is responsible for the conservation, management, and protection of whales, dolphins, porpoises, seals, and sea lions under the Marine Mammal Protection Act. We're going to do a little back and forth between presentations today. First, Doug will start us off by providing some background information about marine mammals and noise. He'll talk a bit about the acoustic interaction potential for some of the sounds in the ocean. He'll also touch on some of the outputs from the wildlife and offshore wind project he is leading at Duke's Marine Lab. What are they monitoring and why, and how that information contributes to the regulatory process. Then Jaclyn will share how NOAA's Office of Protected Resources evaluates the potential effects of offshore wind activities on marine mammals under the Marine Mammal Protection Act. She will also talk about the general mitigation and monitoring measures that are put in place to ensure the protection of whales. We'll then come back to Doug to learn a bit more about his ongoing research. As you think of questions for Doug and Jaclyn, please enter them in the Q&A box at the bottom of your screen. We will hear both presentations first before the Q&A portion of today's program. Thank you again so much for joining us today with open minds and your interest in learning about whales. Doug, I'll pass it on to you now to get started.
Super, Tricia. Thanks very much for the invitation. It's been wonderful to interact with you and the other folks at TNC to put this together. So I will just go ahead and get started, and I'll do my best to do everything that we can to cover this topic. So, as Tricia said, I'm at the I spend most of my time at the Duke Marine Lab, but I am on the faculty in the engineering school and the School of the Environment at Duke, and we'll come to the Wildlife and Offshore Wind Project in a bit. But just a little bit of background, and I'm gonna have to move pretty quickly, so we don't need to get really hunker down into these slides, but there's a few that are really important to set a little bit of the stage. I'm not going to go through all four of these even, but suffice to say that there's documented in a lot of different places in a lot of different ways, and for many years, that the ocean that we're dealing with for developing offshore wind for whales to live in is dynamic. It's always been dynamic, but it's also dramatically changing. And for the most part, it's getting warmer. So I won't go into it, but they're happy to answer questions about it. As I said, there's decades of data, specifically even in this area. So next, I wanted to run through the potential threats of offshore wind development on whales. Noise is the big one, and one of the main topic for today. This NOAA graphic is quite good. It's got several of the sources that you probably imagine, like ships and seismic surveys that are part of this developmental, very different than seismic surveys for oil and gas. Yeah, I'm gonna have to keep going. So they use sound is used in site characterization, sediment type for foundations and cable corridors, and obviously when the piles are driven in for fixed foundation, the floating offshore wind is a different story. And then in operations, wind turbines certainly do create some noise in the water just when they're spinning and operating, but it's really less of an impact and less of a noise source than a lot of people think. Next, increased vessel traffic, which we'll come back to, and I'll mention a couple times, but it is important to note that that's a very small incremental increase over the traffic that exists already along our East Coast. So the U.S. East Coast, like Boston, New York, these places, there's obviously already a lot of traffic, and so the number of boats associated with offshore wind development is relatively minor. And the threats from that are ship strike and noise. Again, incremental increases. The wake effects from wind turbines has come up as a concern for specifically for right whales and the production of food for right whales on Nantucket shoals. We recently finished a panel report at the National Academy of Science, Engineering, and Mathematics, and our primary conclusion, and there should be a link going into that report into the chat, was that, harking back to that first slide, the level of change in the ocean makes it very unlikely that there's even enough of a signal for us to detect in this way. But that's a topic for another day. Okay, as Tricia said, one of the things that's really important to understand is how the sounds that we're putting into the water overlap with the sounds that the animals use. And this graph is a little busy, but at the same time, across the bottom, and hopefully you can see my pointer, is frequency. And so this is whether a sound is very low frequency or it's very high frequency. And we hear from about 20 hertz to about 20 kilohertz. And so if you go up from that into the graph, that's the overlap area that we worry about. Sorry, not here in our hearing range, but the frequency is what gives you the overlap that we are concerned about. So all these different sources in light blue are the animals, are the marine mammals. Blue are naturally occurring sounds, lightning strikes and things. The red is all human produced sources, whether purposeful in terms of like a sonar or as a byproduct like shipping. Then you see some other things, and the y-axis is the noise level or amplitude or how loud it is, and so these things are relative to each other. But we'll get into some specifics about that too. It's also important when we say, well, okay, we're worried about the areas where they overlap. Well, what do marine mammals hear? And we just finished a paper a couple of years ago. It was a big review of what we know about hearing effects. And I won't spend a lot of time on this, but we have categories of cetaceans and pinnipeds, so whales and dolphins, and the seals and sea lions. Sirenians are also in here, but they're less of a concern for offshore wind at the moment. And so we describe them. These are all the species. But what I'll do is just also show you a couple of these. These are what we call audiograms. And so again, frequency on the x-axis and threshold level. And the easy way to think about an audiogram is any sound that's louder than this line, so it's higher than that line, the animal is able to hear it. And if it's below that line, it's not able to hear it. There are exceptions. All these squiggly lines over here are individual animals that have been tested and then creating that, that average line, so to speak. The LF line has no lines on it because we don't have any data, any empirical data about what large whales, and this is low frequency animals like baleen whales, that they can actually hear. So it's an important thing to keep in mind. A couple things about the sources. Some of these things folks will have heard of, certainly air guns and air gun arrays, and some of them are quite loud. And you also remember that source levels in decibels are a logarithmic scale. So the difference between 230 and 240 is not 10, it's 10 times. So it's a logarithmic scale. So these things are quite a bit louder, much louder as you go up that scale. I also wanted to put this in because this is some of the sources that are used. And you'll have seen boomers and bubble guns and sparkers and sub-bottom profilers and multi-beam echo sounders. These are the statistics, if you will, on those sound sources. But for a couple things that are really important here is that we can eliminate some of these sources, and the Fisheries Service has done this because they're considered de minimis in terms of their impact, because either the animals don't hear that high, so these very high frequency sounds out here can be essentially disregarded because the best that an animal can hear is below 200 kilohertz. And so that's where we can cut that off. And also, if we don't have any sound energy making it out at a certain distance, the source is also de minimis in the case of these impulsive sources. And so we can block out everything below 180. That's 180 source level. And once it gets even 10 meters away, it's down to 160 effectively. So we can disregard those sources too. So it narrows what we really have to deal with. This I won't get into, but this is us correcting for what we know about the hearing of animals and how that impacts their what they can hear. Okay, very quickly, what do we know about responses of whales to anthropogenic noise sources? And that's sonar, seismic, shipping, pile driving. I'll leave that to Jaclyn. The behavioral responses that we've documented in several species, lots of species now, and then the physiological responses, those measurements are really in their infancy, but we're getting better about that. It's also really important. One of the things that we have documented quite well now is that some species, like humpbacks, are less responsive to various sound sources. And showing mild behavioral responses to things, while some, like harbor porpoises and beaked whales, are more sensitive than average, and average is in quotes because there's a lot of things that figure into average. With respect to drilling down into right whales, we do know that right whales respond to some signals, but they also tend to ignore things like shipping noise, and that's a whole nother discussion as well. We don't have any data on how right whales respond to impulsive noise like pile driving or some of the seismic sources, but we do have good insights from their cousin, the bowhead whale. So that has also informed what we've done. Okay, large whales and wind. Just to bring it back and set the stage for Jaclyn. What do we know about the strandings of, in this case, humpbacks along the Mid-Atlantic? Pointy-headed scientists like me don't like to say things unequivocally and say that we absolutely know this, but I can say that I have seen no evidence that any of the activities associated with offshore wind development cause or have been in any way connected to the whale strandings that we've seen over the last couple of years. And there's a very good paper Leslie Thorne and Dave Wiley put together of all of the activities that have happened since 2016, I believe, and all of the strandings. And there is no overlap in terms of time or space in those activities. And there's several reasons for that, and we can get into that. We certainly are looking at we're constantly working to better understand potential responses and impacts to the animals. Lastly, a word about right whales. This is kind of a sad and staggering statistic that if you remove newborn mortality, 100% of the documented right whale deaths in the last 2 years have been caused by humans. And most of those, almost all of them that we've been able to actually determine a cause of death are from ship strikes and entanglement. And this whale was hit in a catastrophic blunt force trauma. And the entanglement of animals can be lethal, but at the very least, a sublethal impact can cause them to delay pregnancy for several years, or cause them to be compromised in some other way. So these are it's not good for them to carry a line around. It's tough enough to move through the water than it is to carry some line with you. Okay, that's it for the intro. I will stop sharing and over to you, Jaclyn. Oh, Tricia, back to Tricia,
Yeah,
sorry.
no problem. Thank you, Doug. That was helpful context. Jaclyn is now going to talk about her work with the Office of Protected Species.
Thanks, Tricia, both for that introduction and the invitation to be here. I'm very excited. Hello, everyone out there in the virtual world. My name is Jaclyn Daly. I am NOAA Fisheries MMPA Offshore Wind Team Lead. I work out of our Office of Protected Resources, which is located in Silver Spring, Maryland. And we're the office that actually issues all of the MMPA incidental takeoff authorizations for the entire country. Today, I'm going to be talking more about the regulatory processes. Doug's going to stick to the science. He did a great job. Thanks for that introduction, Doug. And really talking about our role in implementing the MMPA with respect to offshore wind. So let's share my screen here. All right. You guys good to go? You can see that?
Yes, all good.
Thank you. Okay, so just a quick agenda slide here. I'll give a brief introduction to offshore wind and my team, provide an overview of the MMPA, discuss some statutory definitions and processes, review some general offshore wind mitigation, monitoring and reporting measures that we require of developers. I'll explain some compliance needs with other applicable environmental laws like ESA and NEPA when issuing authorizations, and then wrap up with just a brief overview of other NOAA efforts that support marine mammal conservation with a focus on right whales. So as we all know, offshore wind has really boomed over the last few years in the US. BOEM is the federal agency responsible for approving offshore wind development in the US. And this is just one of their snapshots of their lease areas in the Atlantic. But most of us know that offshore wind is also being developed throughout the US in the Gulf of Maine, the Gulf of Mexico, and the Pacific Ocean. So in response to this offshore wind boom, NOAA had to develop a MMPA regulatory team to respond to the requests for authorizations that were starting to come in the door. Many of my team members, many of them, but not all of them are shown here, they've really dedicated their education and careers to marine mammal science and conservation. I myself, I have a bachelor's in marine biology from the College of Charleston and a master's degree in conservation biology from the University of Queensland in Australia. In addition to those degrees, I spent about 10 years in the field in my younger days collecting data on a variety of marine mammals to promote conservation, including the endangered southern resident killer whales. I've flown right whale surveys, participated in research cruises, such as the beaked whale behavioral response cruises, and even have done some work doing some dolphin health assessments, looking at the impacts of the Deepwater Horizon oil spill on dolphins. So, we've all talked about the MMPA. What does it do? The MMPA, first and foremost, it prohibits the taking of marine mammals unless authorized by NIMS. That's kind of like the very beginning of the MMPA. It also allows for take for subsistence uses. For offshore wind currently, that's not really a factor. And the MMPA also establishes other requirements and programs such as the Marine Mammal Commission to support conservation of marine mammals. So there are many definitions in the MMPA, and the most common one that we use, the most common term, is the word take. So what does that mean? By law, take means to harass, hunt, capture, or kill, or attempt to do these things. And there's a common misconception that take always equals mortality. We often hear that, NOAA is authorizing the killing of marine mammals, and that's simply not true. Just trying to hit slides here. So the MMPA further defines harassment, which is a type of take, and breaks it down into two categories. One is the potential to injure a marine mammal, which is level A harassment. This again is not mortality, or the potential to disrupt behavioral patterns, which is often referred to as level B harassment. And you guys, everyone here probably has heard those terms floating around in the world today. This is my kind of attempt to simplify all those words and congressional definitions into something more visually appealing. Essentially, there are different types of take. There's harassment, hunting, capturing, or killing. And then harassment is further broken down into level A harassment, which means to injure, and level B harassment, which is the behavioral harassment. To date, all of our offshore wind incidental take authorizations authorize level A and or level B harassments. Our offshore wind authorizations do not authorize other types of take. So I discussed earlier that the MMPA establishes a prohibition on take unless authorized, and these are some of the ways that one can obtain such authorization. There are commercial fishing permits, directed scientific research permits. Doug has probably more than one of these. If you are having to take measures to protect personal safety or property, there's a section of the MMPA that allows for that. And then, of course, today we're talking about Section 101A, 5A, and D of the MMPA, which authorizes the take through incidental take authorizations. So this is a very wordy slide, and I'm not going to read it all by any means, but really this is just demonstrating that we actually have a process established in the MMPA that we have to go through when we receive an application for an incidental take authorization. So the MMPA states that upon request, we shall issue the requested take of small numbers if, after public comment, we can find the total taking has a negligible impact, it does not have an unmitigable adverse impact on subsistence use, which I mentioned for offshore wind isn't really a factor right now. And we are required by the law to establish mitigation measures that affect the least practicable adverse impact in authorizations, and also prescribe monitoring and reporting measures. So the government uses a lot of acronyms. We love them, but it can be really confusing. So this slide kind of represents how all of those terms break down. So the term incidental take authorization is very generic. It represents two vehicles for authorization. So we have an incidental harassment authorization or a letter of authorization. Both of those pieces of paper that we give an applicant at the end of the process authorizes the take of marine mammals. We do not authorize the construction of offshore wind farms. Like I mentioned earlier, that is BOEM's realm. So we have these two ways we can authorize take. An IHA is only good for up to 1 year. It may only authorize harassment of marine mammals, that level A or level B harassment, and there's a public comment period associated with it. A letter of authorization can be good for up to 5 years. It may authorize mortality or harassment. It does require, and this is set forth in the law itself, is that we have to issue regulations before we issue the letter of authorization. And there's 2 public comment periods associated with an LOA. One is at the application stage, and one is at the proposed rule stage. And here, rule and regulations are synonymous terms, more or less. We put out what's called a proposed rule and have a public comment period on that. So when we're talking about offshore wind, we look at the types of activities that are involved with development that may incidentally take a marine mammal. Doug talked about noise. Most of our activities are noise generating activities, But there are other activities that have the potential to take a marine mammal in and of themselves, and this includes things like vessel activity or fishing gear activity. So overall, what the types of activities we see in offshore wind development include high resolution or geophysical or HRG surveys, pile driving. Doug mentioned that already. We also have a little bit of pile driving involved at the cable landfall connection sites, which connect the offshore cables onshore. Some developers, but not all, might identify the need to potentially detonate an unexploded ordnance that they find while they're constructing the wind farm. We analyze that, and offshore wind developers are also required to do fishery surveys, and we look at the potential for gear entanglement from those surveys. So after we've assessed and understand all of the activities that are involved in any particular project, we have to prescribe those mitigation measures in accordance with the law. So these are some examples of the general mitigation measures that are required under our incidental take authorizations. First and foremost, we actually tell developers that they cannot install piles at certain times of the year. Our seasonal restrictions are centered around reducing the impacts to North Atlantic right whales because of their status, but those seasonal restrictions also protect other marine mammals as well. In general, the base case, if you will, seasonal restriction is January through April, but we do look at all of the best available science associated with that project in that location and can extend those seasonal restrictions to other times of the year. All pile driving of the foundations require the use of noise attenuation systems. The government, including NOAA, BOEM, the Department of Energy, and developers themselves are really advancing the technology for quieting. That can mean looking at different ways to install piles or looking at noise attenuation systems that reduce the noise from pile driving. Like I mentioned, there are some fishery surveys involved. If a developer is using gear that could entangle marine mammals, we can prescribe measures that limit the types of gear that they use or actions that they need to take if there's risk of entanglement to a marine mammal during those fishery surveys. We also go above and beyond with our vessel strike avoidance measures. There are regulations in place, federal regulations in place, that limit speed and approaches of right whales in the Atlantic. Our incidental take authorizations actually go above and beyond those. For example, you might be familiar with the seasonal management areas that are required currently for vessels over 65 feet. We actually apply that to all vessels, regardless of size for offshore wind. The dynamic management areas established in the current vessel speed rule are voluntary. In our offshore wind authorizations, we actually require that they abide by those speed restrictions during DMAs. Whereas the rest of the public, other industry, recreational boaters, do that voluntarily. Back to pile driving real fast and other sources that can create noise. We establish clearance and shutdown zones. So if an animal is seen swimming in a certain distance from a pile or HRG survey source, the developer has to delay operations of that source. And if the activity is already started, they have to shut down that source if an animal is within a certain zone. So those are our mitigation measures that reduce the impacts on marine mammals. But to trigger those mitigation measures, we have to have marine mammal detections. And I'm speaking specifically to the clearance and shutdown zones mitigation measure here. So during pile driving of the foundation piles and some HRG surveys, we actually require a lot of observers on the vessels, either on the pile driving vessel themselves or on dedicated vessels that circle a certain distance from the pile. And there's a lot of observers out there. We also require the use of passive acoustic monitoring, which can also trigger clearance or shutdown of an activity so that those mitigation measures are being effectively implemented and have the most protection to marine mammals. As far as reporting goes, we require very frequent reporting during construction, situational reporting, which is meant to both ensure that the developers are doing what they're supposed to be doing, but also to raise awareness about the presence of marine mammals in an area. So for example, a developer has to report very quickly if they see a right whale, and then those detections are transmitted into something like Whale Map or the sighting network so that other people are aware of the presence of marine mammals as well. So just a quick look at other laws. We don't issue authorizations just looking at the MMPA requirements. Issuance of a take authorization is a federal action, so we are required to comply with other applicable environmental laws. For offshore wind, these are most notably the Endangered Species Act and the National Environmental and Policy Act. For the Endangered Species Act, we consult with ourselves. It's a little bit weird, but we're not the office that's doing that. That gets farmed out mostly to our regional offices, who are specialists in the ESA, and there's resulting biological opinions that are issued in response to the action agencies requesting consultation. And then BOEM is the lead action agency on developing environmental impact statements. We work very closely with them to ensure that the analysis within that EIS reflects the best available science with respect to the marine mammals that are under our protection. And then we work with BOEM to adopt that EIS and sign joint records of decisions with them for offshore wind development. And finally, this is my last slide. This is just a nod to the investments that NOAA is making in general to protect North Atlantic right whales. We have what's called the Road to Recovery. If you haven't seen it, I really encourage you to check it out on our websites. There's two main goals, which is addressing the threats to right whales and reducing those threats. And also the second goal of actually monitoring the progress of reducing those threats to right whales. We also recently completed a joint strategy with BOEM called the North Atlantic Right Whale Strategy, which identifies a number of ways to further the conservation of right whales in the face of offshore wind development. And that's all I have here. Thank you, Tricia.
Thanks so much, Jaclyn. We're going to head back to Doug now, who's going to talk a little bit more in a little more detail about his work.
Thank you, thank you. Thank you, Jaclyn. That was fabulous. All right. Back up and running. Okay. So with all, now that you all know how to do regulation, we're going to teach you science. So by the end of the day, you'll be ready to head out and save the world and save right whales. I thought it would be good to just give folks some idea of what one of the things that's going on. This is quite a large project, but it's the Wildlife and Offshore Wind Project, which I lead through Duke. It's a big consortium of researchers and which includes NGOs and other academic institutions and places like the New England Aquarium, and there's a lot of us in this. And what we're endeavoring to do is to create a systems approach, which includes things like risk assessment approaches, obviously collecting data that we use to model what are the responses that animals may or may not have to some of these activities, that, as Jaclyn described, the behavioral responses. I will say that hearing injury is very unlikely, very, very unlikely in these situations for lots of reasons, not the least of which is the abatement. But funded by the Department of Energy and BOEM, primarily by DOE and their Wind Energy Technologies Office. So I'll just launch in. Okay, so I do want to run through this, and it may sound a little wonky in terms of risk assessments, but we can't know everything, and so we need to take what we have and assess the risk as we understand it and what it is to those animals. So the framework type 1 that I'll just briefly talk about is commonly referred to as occurrence, exposure, response, and consequence. And this is where when we don't have a whole lot of information, hopefully we know something about the responses of the animals and can maybe describe the consequences. But these frameworks move up in terms of their sophistication, but also their need for data. So we can start off pretty simply where are animals and when are they and what are they exposed to. And so these four figures, minke whales, fin whales, North Atlantic right whales, and humpbacks, show the occurrence of these animals, the densities around, in this case, the Vineyard Wind 1 site with a 10-kilometer buffer. And what it shows is by month, what the density is of the animals. And those densities are generated by the Duke Marine Geospatial Ecology Lab, Pat Halpin's lab, who's also a co-PI. But these density estimates are used by the Navy, they're used by NOAA, they're used by other folks around the world, actually. Pat's lab is quite well known for that. So when Jaclyn mentioned the seasonal restrictions, this is when right whales are expected to be in the area, and this is when they're expected to be at low density, not zero, but at low density. So that's when we target those things. But you can see it doesn't overlap with when fin whales are supposed to be there. And fin whales also happen to be ESA listed. So these things are not always straightforward. It's just saying, okay, don't pile drive from January to April. Okay, moving on. The next type of framework is what we kind of refer to as a semi-quantitative approach, which does things like assess the vulnerability on a scale, and then also assess what the exposure is of a given animal or species. And you try to, everybody likes stoplights. Well, most people hate stoplights when they're actually driving, but they can be pretty useful in analogy. And I don't have time to go into all the rest of these, but suffice to say, this is, scientists, pointy-headed scientists, I refer to myself, we would rather not use a semi-quantitative thing. We'd rather be fully quantitative, but we just don't have enough data in a lot of these situations. And other folks, just so you know, don't trust me to do statistics. We have one of the partners on the project is the Center for Research in Ecological and Environmental Monitoring in the Mathematics and Statistics Department at the University of St Andrews in Scotland. So these other frameworks, these other risk assessment frameworks, we could go into. But that's the idea, is to try and get a handle on it. Fully populated, the most sophisticated, the most data hungry are what we call population consequence models, roughly. And I won't go through all this, but basically what we're looking at is we take some kind of exposure, whatever the dose is that actually reaches the animal. Does it cause a physiological or behavioral response? What does that do to the animal's survival, reproductive capability? And what does that mean actually mapping onto the population dynamics? So not simple, as you can already appreciate, and we try to do this with multiple individuals. We do have essentially a fully parameterized model of this for North Atlantic right whales. Very interesting stuff, and a cool evolution to have seen in the last few years. The last one I'll say just quickly, and this is something we developed for WOW, for Project WOW, and that's survey design tools. And so, the question is, okay, well, are fin whales affected by offshore wind development? It's a big question. And so at every step, we try to think through, okay, well, for this part of the question, we need to know that. And for that part of the question, we need to know this. So designing the surveys, whatever kind of survey that is, in this case, aerial surveys over the Vineyard Wind site, what kind of power do we have to be able to detect whether or not there is a change? And those are, I'll leave it at that. We can talk more about it in questions. Okay, so our study sites are, as I said, the Vineyard Wind site here to the southwest of Nantucket and south of Martha's Vineyard. And then the other one, we're working with Equinor on their Empire Wind 1 project here. And when I say that, we have an external advisory board for the WOW project, which includes primarily developers, which was by design, but also representatives from ENGOs, from TNC, and from other groups, Audubon, among others. But one of the reasons that we partnered with the developers was so that we could say, okay, if we can play together, then maybe you can give us some information about when you're going to be doing these activities, precisely when, so that we can get out there and actually sample what the animals are doing, so we have a realistic assessment of what's going on. So that's actually worked very, very well. I'm going to fly through this from the sailing vessel Song of the Whale, which is no longer owned by IFA, but supported by IFA. We tag, in this case, fin whales. We've focused on fin whales because there are very few right whales around when the pile drive, when the construction is actually happening in Vineyard Wind in this case. But fin whales we know relatively little about in this area. So we'll put tags on it. I'll come back to that a little bit. We take really nice pictures of them from above and do things like measure them. You'll also notice that this animal has prop scars, so they're ship strike problems for fin whales as well. These chevron patterns are really interesting. They're individually unique, so that we can identify the individual whales that we've taken pictures of. We also collect snot, which hopefully made you laugh. The snot bot, biologists don't really care about bodily fluids too much, and so, but we can learn a lot, actually more than you'd think, from collecting snot, and I'll come to that in just a minute. Then we have a couple different acoustic recording methods. One of them is this floating single hydrophone, which is easy, it's inexpensive. We can dump it over the side whenever we need to, and we can record and get the data back. And then we also tow a set of hydrophones, an array of hydrophones off the back of the ship, and then we can listen constantly for what's going on in the water. All right, I'll play this movie. We'll hopefully it's playing over your servers, whatever it is. So this is the view from the drone of a whale that's about to be tagged. There goes the tag. It doesn't look like it stayed on, but it's on. You can see it under the water. That whale also has a vessel strike scar. And you can see it again as it comes up. The birds are that bird is trying to eat the tag because it sees it as some, little object that maybe can make lunch out of. So we've gotten good at this, and it's an absolute game changer in terms of getting devices on the animals. These devices, you see the suction cups here and the antennas coming out the back. They're non-invasive. They just sit they suction to the animals for hopefully a long time. Sometimes it's only like 4 seconds, and they just fall right off. But these are high resolution acoustic recording tags. So they actually record the motion of the animal as it's underwater. It's like putting an iPhone on the back of a whale, and it's recording all the sounds that it makes as well, and the depth of water, the depth of dives. Here's the snot bot. I'll play this as I talk about it. So believe it or not, in your exhale, we can do things like measure hormone levels, and we have successfully measured 5 different hormones: cortisol, aldosterone, and progesterone, testosterone, and androstenedione, which was a surprise. So this is a mix of sex hormones and then also stress hormones. And there's the tag on that whale. So the drone pilot sits back and waits for the whale to come up and then flies right through the snot cloud. We also get skin samples from suction cups that we use for the genetics, for the stock of the animals, the sex of the animals, and maybe other things like stable isotopes. And I mentioned the photogrammetry and photo ID. And there you go, there's a fin whale. They're spectacular creatures. Okay. I won't go through all this, but we've done, even for me, surprisingly well. I've been tagging whales and doing this work in exposure to noise since 1999. Well, even before that in graduate school. But here's a sound that we recorded from a fin whale. Hopefully you're able to hear that. I'll crank it all the way up and just play it one more time. So this sound to a fin whale might not sound like much to you, but it's very sexy for fin whales. This last thing here was what I'll talk about in an opportunistic, BRS stands for behavioral response study. So one of the main ways that we try to understand how these animals respond to and are impacted or not by sound is to conduct these response studies where we play sounds to the animals, or they come near a ship and we're measuring what they do. All right, I've got to keep rolling. Here's what it sounds like to have a fin whale hearing pile driving. So this is pile driving sounds sped up 5 times, because otherwise it's too slow and it's too low for us to hear, really. We can talk more about it. This is the dive profile of the whale. This is the pile driving time over here. And we don't have enough to really say a lot, but the animal stayed in the area and kept feeding. And this is pretty typical of what we've been hearing when we're out there. Okay, last thing I'll do is Jaclyn referred to the passive acoustic monitoring, which is something that has become very, very common. It's I won't go into it too much, but this is Nantucket Shoals here and the edge of Martha's Vineyard, or of Nantucket. And this is the carpet of hydrophones that's out there listening all the time. These are not all out at the same time. They're different intervals, but it has become a very important tool in our toolbox, our tool belt. It is not the answer. It is not the end all be all, because it relies on the animals to make their sounds, and they don't just wander around the ocean like saying hi, hi, hi. They don't do that. Sometimes they don't vocalize at all. So it's important that we keep that in mind. All right, we did some transmission loss experiments, but I'm going to go ahead and move on. This was just to make sure we had a good idea of how far away we could detect right whales in this case. Okay, and that's me.
Thanks so much, Doug, and thank you, Jaclyn, for those great presentations. We have some great questions in the Q&A, and I want to get to them. And just, I'll let people know now, I'll say this again, but if you have questions, please put them now in the Q&A at the bottom of the screen. And we only have an hour today. There are a lot of really excellent questions. We may not be able to get to all of them, but we will endeavor to try to answer those questions after today's webinar. Jaclyn, I just wanted to start with you. You can come on screen. Yeah, great. I guess I want to understand why an offshore wind company or any activity that's planned for the ocean would seek harassment authorization. Like, what are the activities that they're telling you about? Why do they think it needs a harassment authorization? Especially if they're doing all this mitigation on top of it. And then maybe if you could just talk a little about like the types of activities that would kind of trigger that authorization, and then the types of activities that you're looking at that might trigger like the take authorization. That would be a helpful clarification. Just some examples of like what they might be doing and why they're asking for the authorization.
Sure. Great question, Tricia. Happy to answer that. So, like I said, the MMPA is a law in the land that says you cannot take a marine mammal unless you have authorization to do so from NIPS. And so basically the reason developers or any other applicant who's doing an activity that may incidentally take a marine mammal comes to us is to comply with the law. And if they did not, and they did take a marine mammal, then they would not be in compliance with the law. So it's essentially following the law. So our program is much bigger than the wind team. We have a program of over 20 folks who, like I mentioned, issues incidental take authorizations for the entire country. Common activities include coastal pile driving, so like port construction or dock construction. We have scientific research surveys that might be using some type of sonar or air guns to research the bottom, like the National Science Foundation does some research for which we authorize incidental take. We even authorize incidental take for researchers doing abalone research, and they disturb seals on the beach during that. And of course, we do the authorizations for military readiness activities. And those are probably off the top of my head kind of like the types of activities that we authorize take for upon request from the applicants.
And what about for harassment?
Those are for harassment. Really the only, in military readiness activities, there might be a small amount of mortality involved in those authorizations, but for the most part, harassment, which is that level A and level B types that I talked about, is the type of take that we're authorizing for all of those situations.
I see.
You did mention about like, even though they're doing mitigation, and unfortunately, I mean, I would love to not have to issue authorizations for anybody, which means that we've mitigated all the takedown to nothing or some de minimis level. But that just isn't practicable. We just don't have for example, from pile driving, the quieting technology yet to reduce the sound levels to the degree where there is not that potential for harassment. So sometimes it's just not practical to actually mitigate all take away.
So, Doug, I wanted to go back to a question that I had. You had said something, I think, along the lines of the vessel traffic that's added from offshore wind activities is really minimal compared to like the rest of the vessel traffic in the ocean. And I guess I was curious about, is it the number of vessels that we're worried about, or where the vessels are going, or the speeds that they're going at? And
Yeah.
are all those
Yeah.
things important, or? How do you draw
Well,
that conclusion?
yeah, the number is the biggest thing because if you looked at a given day of the number of vessels, either large or small, to go in and out of that if we just look at the area around Martha's Vineyard, you've got all of Rhode Island to service, Newport and all that, New Bedford, several ports in Massachusetts. You've got Long Island, all of those places. There are vessels coming and going. So the number of vessels that, for example, in this example, the Vineyard Wind runs out of New Bedford, maybe they have a vessel a day, but it's one out of 150, 200, something like that. I don't have any idea what the actual numbers are. You can get that, but so the numbers is one thing, and it's just people say, well, it only takes one vessel to hit a whale. I come back to the risk assessment part of this, and where should we be putting our effort in terms of what are we mitigating for? And I'll come to the speed, and the speed. We don't actually have. There are a few compilations of observations of vessels hitting whales and the speed, and it stands to reason that a vessel going slower than a fast one causes less damage. And slowing down is effectively like going into a school zone, right? That's the best analogy. When you go into a school zone, it does three things. One is you slow down so that if you do interact with a kid, there's less chance of serious injury, which the same thing stands for speed and hitting whales. The second is that you're more alert, right? You go into an area and you think, oh, there might be a kid here, and so I should pay attention, right? And then the last one is that in theory, it's quicker to stop. Now, for a large vessel going even 10 knots, it takes them a long time to stop. So stopping and turning are not things that they do particularly well. So on the noise side, vessels are in general quieter if they go more slowly. But the caveat there is, again, if you're in a busy shipping area, if the cargo ships are going 20 knots down the New York shipping lanes, and they're not regulated for speed, then they're making way more noise than one offshore wind vessel that's going 10 knots. They're not even really adding to the noise level of the area because those louder ships just dominate completely.
Jaclyn, can you talk a little bit about whether, I guess I don't know the answer to this, is the vessel, I know I'm familiar with the 10 knot speed restriction for offshore wind vessels. Is that a speed restriction that applies to other vessel traffic in the ocean?
No, we've restricted offshore wind vessel speed and more so than regular traffic in the ocean in accordance with federal law. So right now, the current vessel speed rule enacted in this country limits vessels 65 feet or over to 10 knots or less in certain areas at certain times, full stop. Other vessels less than 65 feet can go over 10 knots in those areas during those times. There is that voluntary dynamic management area framework that I discussed, where the general public or anybody in a vessel can voluntarily reduce their speed, but they're not required to. The offshore wind vessels are required to reduce their speed during dynamic management areas.
Okay, thank you. So for a question from the chat, we have a lot of questions about sound, which I get because it's just a very scientific kind of area. So I'm wondering, I guess I'll start with Doug, if you can help us understand, how do you determine the frequency that a whale can hear at versus just like whether they're accustomed to the sound or they're cool being there even though they can hear it, not bothered by it. And does that matter?
Oh, it definitely matters. It's a really good question, and there's kind of multiple layers to it. As far as what they can hear, I mean, when I was a kid, anyway, you go to the nurse's office and they put the headphones on your head, and they'd play tones in your ear, right? And you raise your hand whether you can hear it or not. And so that's how we test hearing, is to play things quieter and quieter until you can't hear them anymore, and then we know what that threshold is. We've done that with a lot of cetaceans. It's a little harder with the large whales. In fact, we just have the first one of a baleen whale with a minke whale that they did that an audiogram study in Norway. So there are a couple other ways that we can do it. One of them is anatomical, which you actually look at the inner ear of a whale that's dead, and you look at it in the lab, and you can tell something about from the structure of the ear what those animals can actually hear. when it comes to, if they can hear a sound, then there's a few things that happen, right? Either they're not paying attention. They don't like it and they do something to leave, and that's a very common response, and not typically very fast or necessarily in an alarming way, but it's kind of like you're walking down the street and there's a jackhammer on the other side of the street, or on your side of the street. You kind of just reflexively cross the street and walk on the other side because it's not quite as loud. So that does happen. The animals sometimes, even if they are annoyed, they might stay in an area. And if there's not really any consequence to them, that's what we call habituation. So that's a sound that doesn't have any negative consequences for you or for the animal. And so they've learned to stay. Now, they may also not respond behaviorally and outwardly, but do respond physiologically. Their heart rate goes up, some of these other things happen, but they stay there because the food is there or whatever. My quick analogy is, if I put a really annoying sound in your broom closet and one in your refrigerator, you may never sweep your house again because you don't want to open that door, but you're going to go in your refrigerator again, right? Because you've got to get food, and you're going to tolerate that noise. So those are very difficult things to tease out. I mean, I will say that luckily, like I said, we don't have any evidence that any of these activities has really disturbed these animals in any significant way at all. But the jury remains out.
I don't like what that example said about my snacking habits, but it's a good example. I'm also curious, Jaclyn, if we are getting information back. So, do we know how frequently offshore wind companies during operations like pile driving or site surveying are actually noticing a marine mammal and having to pause operations? Like, do they have to report that? Do we have information about whether these mitigation things like bubble curtains are working?
Yes to both of those. So on the reporting side, we actually require very frequent reporting during pile installation on a weekly basis. And so in those weekly reports, they indicate, the number of marine mammals that they observed or heard from those passive acoustic monitoring systems. And if they implemented any mitigation, if the hammer was on during the sighting, if it was off. So they do report if they had to take an action, such as delaying or shutting down. I will say, because we have established that kind of concept of don't start if you see an animal, the majority of those actions are not starting and waiting for the animal to leave the area. If there are any developers on the phone who have started construction, they will probably tell you there have been several hours, days of delaying in totality because of marine mammals. So it really is, we would rather the activity not start first instead of shutting down. And then, of course, once they do start, we do take into account any, safety measures that have to be in place if something just precludes a shutdown immediately. So we are getting those reports on a weekly basis. They're interim reports. We also require annual reports, and those are always posted on our website. So if you go to our, if you kind of do a quick Google for NOAA incidental take authorizations, you'll go to our website. It has every single authorization that we are processing, issued, or even expired back to a certain year. And then when you click on that page for that project, you'll find all of the monitoring reports that have been deemed complete, which are for offshore wind. It's our annual reports. And then with respect to your bubble curtain question, we actually require pretty extensive what we call sound field verification, or SFV, wherein the developers are monitoring the sound. Now it's during every pile installation, and we make them do very thorough sound field verification at multiple distances from the pile in different azimuths during the first few piles that are installed, and then continuing with what we call abbreviated sound field verification, which is a measurement at 750 meters from the pile, which is how they do it in Germany. So we've taken some lessons learned from the European offshore wind farm development there. And so every pile is measured so that we can understand the sound fields coming or being generated from the pile driving. If we see kind of spikes, we can tell if there's something going on with the bubble curtain, for example, that's not quite working well, and they're required to make adjustments for that.
Great. I'm going to ask Doug if you have a response to just put it in your chat. We are over time today, and we could have so much more to talk about. We should really do a month of webinars on whales. I'm sure we'd have a lot of attendance, but I want to thank everyone for joining us today. Thank you again to all of who support TNC so generously. We will be sending everyone a follow-up email in the with a link to a recording of this webinar. So if you're enjoying our webinars, please be sure to share them with your friends and colleagues. You can also follow us on social media at conserve_MA on Facebook and Instagram to keep up with our work and get updates on upcoming virtual opportunities to connect with us. And as always, you can register for future webinars at nature.org/MA webinars. And during our next webinar in this series, which will take place on October 10th at noon Standard Eastern Time, we'll be talking about how research helps maximize benefits and reduce impacts to birds in the offshore wind context. And we'll hear from 4 different experts. We hope you can join us then. Thank you again and have a wonderful afternoon.